There's a liquid that costs less than $1 per application. You apply it with a cotton swab to the inside of a dead electrical outlet. You wait 60 seconds. Then you plug something in, and the outlet works. The outlet that has been dead for months. The one your electrician said needed to be replaced. The one a licensed contractor quoted you $150 to $400 to diagnose, remove, and swap out. $1. One cotton swab. 3 minutes. And the outlet comes back to life as though nothing ever happened. This is not a party trick. This is contact chemistry. The fundamental science behind electrical conductivity and oxidation has been understood for over a century. Every radio technician who repaired military equipment in World War II knew this. Every telephone lineman in the 1950s carried a version of this in their kit. Every aerospace technician who services avionics knows it today. Oxidized electrical contacts are one of the most common causes of electrical failure across every industry in the world. And the solution has always been the same. A solvent that dissolves the oxide layer and restores clean metal-to-metal contact. $1. The electrician standing in your hallway does not want you to know this exists. Then someone in a corporate boardroom did the math. The electrical contractor services industry in the United States generates over $200 billion annually. Residential outlet and switch replacement is one of the most common and highest margin service calls. The material cost to replace an outlet is between $2 and $8. The labor charge is between $100 and $400. A $1 liquid that eliminates the need for replacement in the majority of cases is not a product. It is a service call elimination device. And what eliminates service calls does not get recommended during the service call. Welcome to Forbidden Fix. If these stories matter to you, hit subscribe and the bell. This is where we dig up what industries spent decades trying to erase. The liquid is electrical contact cleaner. Specifically, isopropyl alcohol at 99% concentration, or a dedicated contact cleaner spray, such as WD-40 Specialist Contact Cleaner or CRC-QD Electronic Cleaner. These products are available at any hardware store or electronics supplier for between $3 and $12 per can, providing dozens to hundreds of applications. The cost per use is less than a dime. To understand why this works, you need to understand why electrical outlets fail in the first place. And the answer is almost never what electricians tell you. The vast majority of dead outlets, meaning outlets where nothing plugs in works, fall into two categories: oxidized contacts and loose terminal connections. Both are invisible, both are simple, and both are diagnosed as needing full replacement by contractors who charge by the service call. Copper is the dominant electrical conductor in residential wiring. It is an excellent conductor of electricity when its surface is clean, but copper oxidizes readily in the presence of air and moisture. Over years of use, a thin layer of copper oxide forms on every contact surface inside the outlet. On the internal contacts that grip the plug blades, on the terminal screws where the wires attach. On the backstab push-in connectors that cheap outlets use instead of terminal screws, copper oxide is not a conductor. It is a semiconductor with dramatically higher resistance than pure copper. When an oxide layer forms on an electrical contact, it introduces resistance into the circuit. The resistance reduces current flow. Under light load conditions, the outlet may seem to work marginally. Under higher loads, the oxide layer becomes a bottleneck that prevents the circuit from functioning. The outlet appears dead, but the copper is still there. The wiring is still connected. The circuit breaker is fine. The only problem is a microscopic layer of oxide on the contact surface. Isopropyl alcohol at 99% concentration is an excellent solvent for copper oxide and other oxidation products. When applied to a corroded contact, it penetrates the oxide layer and disrupts the ionic bonds holding the oxidized copper together. It dissolves the contamination and leaves behind clean metallic copper with its original conductivity intact. The alcohol evaporates completely within 60 seconds at room temperature, leaving no residue. The contact is restored. Dedicated contact cleaner sprays use similar chemistry with additional defluxing agents that remove flux residue, carbon deposits, and biological contamination from contacts in addition to oxide. The second common cause of dead outlets is loose terminal connections. Modern residential outlets use two types of wire connections: terminal screws, where the wire is looped around a screw and tightened, and backstab connectors, where the wire is pushed into a spring-loaded opening. Backstab connectors are notorious in the electrical trade for one reason. They use a thin spring steel contact that grips the wire. Over years of thermal cycling, the spring weakens, the wire seat loosens. Electrical arcing occurs at the intermittent contact point. The connection degrades. The outlet becomes intermittent or fails completely. The fix is often as simple as pressing the wire more firmly into the connector, or on outlets with terminal screws, tightening the screw with a flathead screwdriver. A screwdriver that costs $2, applied for 30 seconds, to a terminal that costs $0 to tighten. Before I go further, this video covers the diagnostic and cleaning method. Inside the Forbidden Fix vault, I have compiled complete electrical maintenance guides covering outlet testing protocols, GFCI troubleshooting, loose connection identification, panel inspection basics, and the diagnostic process that licensed electricians use to identify and fix electrical faults in the exact sequence that minimizes labor time. The link is in the description. But stay right here and stay safe, because the safety information is as important as the technique. The U.S. military has used electrical contact cleaner as a standard maintenance consumable in avionics, communications equipment, and weapon systems electronics since the 1940s. MIL spec cleaning agents for electrical contacts are documented in military technical manuals across all service branches. The telecommunications industry has maintained copper contact cleanliness as a fundamental operational practice since the earliest telephone exchanges. IBM's hardware maintenance documentation from the 1960s through the 1980s specifies contact cleaning as the first diagnostic step before any hardware replacement is authorized. NASA's electronic assembly and cleaning specifications, documented in ECSS and IPC standards, mandate contact cleaning as a primary maintenance intervention. The science is industrial standard. The application to residential outlets is trivially obvious to any trained technician. It has simply never been communicated to consumers. Electrical contractors generate their highest margins from simple service calls that require minimal time and minimal materials. A dead outlet call typically takes 30 to 60 minutes, including travel. The contractor charges a trip fee of $50 to $100, plus an hourly rate of $80 to $150. The outlet itself costs $2 to $8. The total invoice for a problem that contact cleaner and a screwdriver resolve for under $1 is between $150 and $400. The contractor is not doing anything fraudulent. They are providing a licensed service within a regulated industry. But the system is structured in a way that incentivizes replacement over cleaning and replacement over the 30-second screwdriver tightening that would have solved the problem for free. The information needed to make a different choice is available. It is just never provided on the invoice. If you have made it this far, you understand more about contact oxidation and electrical failure modes than 99% of homeowners who have called an electrician to replace an outlet that needed a cotton swab and 30 seconds. Subscribe and share. One share might save someone $400 on a service call for a problem that costs less than $1 to solve. Here is exactly how to do it. And before anything else, safety first. Turn off the circuit breaker that feeds the outlet you are working on. Verify the outlet is dead using a plug-in outlet tester or a phone charger. Do not skip this step. Electricity kills. Working on a de-energized circuit is safe. Working on a live circuit with a wet solvent is not. Step 1. Turn off the breaker. Verify power is off. Step 2. Remove the outlet cover plate with a Phillips screwdriver. Step 3. Gently pull the outlet from the box without disconnecting any wires. Inspect the contacts. Look for green or dark discoloration indicating oxidation. Check all terminal screws and backstab connections for looseness. Step 4. Using a cotton swab dipped in 99% isopropyl alcohol, clean every visible contact surface. The blade receptor contacts inside the outlet face, the terminal screw surfaces, any visible wire connections. Let it dry completely for 2 to 3 minutes. Step 5. Using a small flathead screwdriver, tighten every terminal screw firmly. If wires are in backstab connectors and appear loose, press them more firmly in or move them to the terminal screw positions if the outlet has them. Step 6. Gently push the outlet back into the box and replace the cover plate. Step 7. Restore power at the breaker. Test the outlet. In the majority of cases, the outlet functions normally. Total cost, less than $1. Compare that to the $250 electrician invoice. I need to be honest with you. This method resolves dead outlets caused by contact oxidation and loose connections, which account for the majority of simple outlet failures. It does not fix outlets that have failed due to a tripped GFCI elsewhere on the circuit. Before spending any money or time on an outlet, always check the GFCI outlets in nearby bathrooms and the garage. A tripped GFCI upstream can kill multiple outlets on the same circuit. Press the reset button first. This method also does not fix outlets where the backstab connector spring has completely failed and the wire is no longer making contact. In that case, the wire must be moved to the terminal screw or the outlet must be replaced. It does not fix outlets damaged by overload events, scorching, or physical impact. If you see black char marks inside the outlet or smell burning, do not attempt this method. Replace the outlet immediately and identify the overload source. This method requires turning off the breaker. If you are uncertain which breaker controls the outlet, test all breakers until the outlet goes dark. If your panel has no labels and you're uncomfortable with the process, call an electrician. Electrical safety is not optional. Your grandfather fixed dead outlets with a screwdriver and a rag. He did not call an electrician to replace an outlet that had a loose wire. He opened the box, tightened the screw, and moved on. Then deregulation and liability law created a world where every homeowner was told that electrical work requires a licensed professional, a permit, and an inspection. Some of that is legitimate safety regulation. Some of it is a professional guild protecting its billing rates. Cleaning a contact and tightening a terminal screw is not dangerous electrical work. It is maintenance. The same maintenance that your grandfather did with a flathead screwdriver and that every building maintenance technician does every week. There was not a safer approach. There was just a more expensive one. Subscribe and share. Every share preserves what they tried to erase. The next vault opens soon, and what is inside might explain how a $2 powder stops an oil leak that a mechanic quoted you $800